Find all zeros, both real and imaginary, for the following polynomials. F of x equals x to the fourth plus 2x cubed minus 3x squared plus 24x minus 180. Now, in order to do this, we need to first find initial zeros, whether they be integer, preferably, or if they happen to be fractions, that's generally fine as well, as long as they're easy enough to come up with what the actual fraction is. But let's graph it and see what we can come up with. So under y equals, I'm going to graph x to the fourth power plus 2x cubed minus 3x squared plus 24x minus 180. And I'm just going to use the standard zoom window, so -10 to +10 and so forth. Okay, so to me, I feel like I can see some decent zeros here at right there and right there. This one looks like it's at +3 and 1, 2, 3, 4, so -5. It looks like. So I'm going to try those out. I can be certain that they're actual zeros when I go through the synthetic division. If I could say synthetic division, that would be helpful. So let's start with the -5 for no particular reason. So 1, 2, -3, 24, and -180. So using synthetic division, bring the 1 down. 1 times -5 is -5. -5 and 2 is -3. -3 times -5 is 15, which makes this -12, which makes this positive. Oh, I'm sorry, this is a +12. And then -5 times +12 is -60. And when I add those two together, -36. And then -5 times -36 is +180, which means my remainder is 0. So -5, in fact, was a 0. I've proven that it's a 0 now. It's not like the calculator, it's going through 5.106 or something, and I just can't quite see that, I've proven that -5 is, in fact, a 0. So I'll do the same then for the 3. And hopefully the 3 is also a 0. But I'm going to factor it out of the remaining polynomial, which are these numbers right here. All right, bring the 1 down. 3 times 1 is 3. That adds up to 0. That's 0, 12, 36, and 0. So that all works out just fine. Now, let me put the calculator away here. I'll get rid of that. This remaining piece here is a quadratic. The leading term is x squared plus 12 equals 0. All right, because this 12 is a constant. This is times x. This is times x squared. That's how I'm doing that. Okay, so, whoops. I need to solve this. So I'm going to subtract 12 from both sides. So x squared equals -12, or x equals the plus or minus square root of -12, which can be simplified. Certainly we can pull I out because there's a negative underneath. And then 12 is 4 times 3. 4 is a perfect square, so I can pull a 2 out as well. So it looks like I could write this. Oh, so I had -5, 3 was a 0, and then also plus or minus 2i root 3. And those are my zeros of that polynomial.